Class 40, number 6. So we have a function, p of x, a log function, 80 minus 35 log base 2 of x. It tells you the percentage of students who could recall the important features of a classroom lecture as a function of time. So x is time, the number of days that have elapsed since the lecture was given. Okay, so the figure shows the graph of the function. So we've got a formula for the function and a graph. After how many days do only 3/5 of the student recall the important features of the classroom lecture? So it says let p of x equal 60. That's because 3/5 is the same as 60%. Right? Okay, so they're telling you to let p of x be 60 and solve for x. So we replace the output, the 60%, the p of x with the 60%, and then I want to solve this equation for x because x represents the number of days. All right, so I want to isolate that log. First thing I want to do is isolate the logarithm. So I'm going to start by subtracting 80 from both sides. So I have -20 equals -35 log base 2 of x. So sort of the trick is to treat this whole thing like it's the variable, right? So solve for that whole logarithm first. And then once you have log x equals something, you change it to an exponential form. All right, so if I want to isolate this log base 2 of x, what should I do next? You got it. Okay, so I have log base 2 of x. 20 over 35, that's going to reduce to 4 over 7. All right, and then I just want to change this to exponential form, right? So my base in log form and an exponential form is the same, right? So this base is 2. And then the other two numbers, because logs and exponentials are inverses, the inputs and outputs switch, right? So right now, x is the input. It's going to become the output, and 4/7 will be my input. So the 4/7 and the x like switch places when you switch to exponential form. So instead of, like right now, this looks like 2 to the x, right? It's going to switch. It's going to be 2 to the 4/7. So you're going to have 2 to the 4/7 equals x. So that's an exact value for the number of days, 2 to the 4/7 days. So I could have my calculator get a better value. 2 to the 4/7. $1.486. See, did they tell us how to round it? They didn't. But... Oh, okay. Oh, all right. 1.486. Let's write that all down and then go to the site and maybe it'll round to 1 decimal place. So that would be 1.5 days. All right, and then locate the point on the graph that conveys this information. So this is x, 1.5. So if we go to 1.5 and find the point on the graph, 1.5 is like right here. That's 1.5 comma 60. And we know that that's exactly 60 because that's what we plugged in here to get the 1.5. So this step with the big green arrow, why does that? No, that's not an exponent. Okay, so so if I had log base 2 of x to something, right? If this was x to say the 21st, right? Then I could take the exponent on the x and put it in front. So it would be 21 log base 2 of x. But this is log base 2 of x to the first. Bringing that exponent of 1 down in front does nothing, right? So if that equals 4/7, instead of using a property of logarithms, I'm using the definition of a logarithm to change this to exponential form, right? So the definition of a logarithm was log base b of something equals a. I'm just making up letters. If you want to change this, this means b is my base, a is my exponent, and that equals x. For example, log base 2 of 100 equals, sorry, I meant to do base 10. Log base 10 of 100 equals 2, right? That's because 10 to the 2 equals 100. Right? So these two say the same thing. Same information said in a slightly different way, like synonyms. All right, so let's see, you've written down, what are those, in that top one, is that log of 5 or is there something being raised to the 5th? Okay. If I wanted to divide this thing by 2, yes, you can do that because you could factor a 2 out of your 12 and your 24 because these things are like their own terms, right? So that would be like if I had written 12x plus 24x, right? You could combine them into one first. So you could say, well, that's the same thing as 36 times the log of 5 and divide by 2, which would give you 18 log 5. Right? You can treat the logarithm as though it's sort of its own term, like an x or a y or something. Yeah, if you were taking log 12 plus log 24, okay, in this case, you can't divide the 2 into the 12 or the 24 because those are part of the log. You could use a property of logs that says, because these are the same base, right? They're both base 10, then I can take the 12 and multiply it by the 24. So that would be log of 240 plus 288, I think. Yeah. And then you can't do anything with the 2. Can't do anything with the 2. Because log is just a special name for a function. Like if I had a function named f, right? If I wrote f of 288 divided by 2, right? You can't put the 2 into the 288. The 288 is an input into the function, right? You could figure out, yeah, like if you knew a formula for f, you could plug the 288 in, get a number, and then divide by 2. Yeah, you could. So let's pull up the calculator. So we'd have to do the log of 288 first, then divide by 2. Yeah, you would do the log of 5 and then multiply by 18. Yeah. Okay, so if you've got some rational function, we'll call it r of x. R will stand for rational. And it's got a numerator and a denominator that are both polynomials. Right? So you find vertical asymptotes by setting the denominator equal to 0, like you said. You find zeros, or x-intercepts, right, by setting the numerator equal to 0. Because the whole fraction is 0 if the numerator is 0. So the whole function will be 0. Horizontal asymptotes, there's 3 cases, and it has to do with the degree of the numerator compared to the degree of the denominator. Okay, so if the degree of the numerator is less than the degree of the denominator, your asymptote is just the x-axis, y equals 0. So that's case 1. Case 2, they're the same, right? The degree of the numerator equals the degree of the denominator. And in that case, your horizontal asymptote is a horizontal line, and its y equals is the ratio of leading coefficients. For the numerator and denominator, right? So for example, if my rational function were 2x squared minus 7 over x squared plus 3, right? Then my horizontal asymptote would be y equals 2 over 1. Because my leading coefficient on top is a 2, the leading coefficient on the bottom is a 1. Or you could just write 2. All right, and then there's a third case where the degree of the numerator is bigger than the degree of the denominator. And in this case, you should divide before you start. Do long division. That's right. Thanks. When the degree of the numerator is bigger than the degree of the denominator, no horizontal asymptote. What's that? Yeah, so we could call this x, right? We don't know what it is, right? So the definition of a logarithm says that my base is 7, right? X is my exponent. Okay, so if I was going to change this to exponential form, this says 7 to what power gives me the square root of 7? 1/2. Yeah. X would have to be the 1/2 power. That make sense? Okay. So this is the formula for half-life for like a radioactive substance, or like a drug in your body gets eliminated using a half-life formula, so an exponential decay. So H is called the half-life, which is how long it takes for half of the material to decay, to go away. M0 is your initial amount. which this little 0 stands for time 0. So this means the amount you have at time 0. And t is time. And there are other ways of looking at this formula, right? So my math lab, I think, instead of using a 1/2, it uses a 2 to the negative 1, which is the same thing. So you can use that if you want. I tend to use this one. I think they wrote it like this. Sometimes it's the same thing. Or sometimes they use a e to the kt formula. In this case, we would have m0 e to the something t and k. Let's see, it would have to be, yeah, it's negative. Yep. And I just have to figure out what it is. Negative kt, where e to the negative k has to equal 2 to negative 1 over h. So if I take the ln, I get negative ln of 2 over the half-life. But you can use whatever formula you're comfortable with. If they give me half-life, I tend to use this formula, right? Why bother doing a conversion if they gave you h? If they gave you k, use this formula.